Welcome everyone to Iowa, and my name is Yuzhou Zhang. I'm a research scientist in the lab, and so today I'm talking about the functional testing process in the MORL. So we started draw your blood as usual, but the difference between the genetic testing and the functional testing, we have to process your sample immediately. Because as you know, the complement system is always on, and if we don't process your sample immediately, everything will be going bad. So we process, we put in a little centrifuge. So this machine can speed really fast, so it can actually separate the cell and the non-cell part. The non-cell part containing the all complement component. The complement, always people, I think you already hear about the plasma or serum. I would like to point out what's the difference. The difference is the serum has nothing, but the plasma has the anticoagulant. So the plasma actually is the blood is not clotting, and we took we call the plasma, and serum as it's after the blood is clotting. Then we take the supernatant, then this is called serum. The difference of the serum and the plasma, actually serum don't have any coagulating protein. So this is important when we look at the functional assay, because what we want to know, when we want to know your level, especially those breakdown products, like C3 breakdown products, and we want to know what's happening in your body. It's not something happening after the blood draw. So it's really needed to stop everything. So we use the plasma to look at the level. But sometimes we need to look at the function, and we want to be able to activate your complement system. In this case, we use the serum for the functional. So actually there's a lot of, I think most of you notice that we have a lot of different kind of tube. So we only use the lavender, or some people call it purple, in the middle for the plasma, and the red, the one behind the one. For the serum. So purple for the plasma and the red for serum. So actually it's really necessary to look at the complement at a protein level. So it will help you to understand your disease, and also we can monitor your disease. Are you going to what's going on over the time? Is your disease going good or getting worse? So at the time of the treatment, we can also predict that a particular treatment will be working for your disease. Some people maybe not respond. So, and we also can, over the time of a treatment, we can follow up your disease by the biomarker, by all the functional testing. So before we go into the actually testing your sample, actually we have to do a simple small job. But when you deal with a lot of sample, it's not a small job. We have to divide your sample. The reason divide the sample because we have so many tests. We don't want just one test accurate and the 9 test is non-accurate. So we take the sample, sort them take out from -80, then sort them and put in a different article, small enough we can throw away after each use, then freeze back in the -80. So the complement protein only stable at -80, and so we have a really large kind of -80, 4 -80 right now in the lab to store all your samples and your articles. So before talking about the complement system, this is actually a non-complement test, and this is the testing of ADAMTS-13 activity. And as you maybe remember, Richard's one of the peacock things, like Carlos peacock things. So TTP is one of the branch of the peacock. It's a non-complement mediated disease, but clinically they are quite same. But the treatment, if we diagnose correctly, they are different. So that's really important to differentiate this TTP. So the uniqueness in the laboratory is we have a really fast turnaround time because some TTP is in the really critical condition, and we give this test only give the report like 24 hours after the receiving the sample, usually on the same day. And so we have more than dozen of the different tests for the complement, looking at for the complement system, and I broke them in the different category. And so the first category is we look at the acquired driver of the disease, which is shown in at the end of Richard's talk. Then Richard is showing those Y-shaped antibody which blocking the factor H function. So this is factor H autoantibody test is most important. Around 10% of you maybe have this positive for this test. Factor B autoantibody is less important because so far we only find one patient is positive for the factor B autoantibody. Then we also, for the second category, we also looking the pathway as a whole. We look at the entire picture of your pathway. So this is including the CH50, APFA, and the hemolytic assay. I will touch base more on this. Then, as Richard talked about, we can look at the individual protein or the complement. Especially, we focus on the complement alternative pathway, the protein. So we can measure the protein level directly, and we also can measure the breakdown products. So this, as you know, the bottom part has used the plasma. The middle part, you have to use the serum. The top part, you have to use either serum or plasma. So this is a more scientific way to look at the complement system. There are three pathways, and a lot of protein we can measure, like C3 usually low at the acute phase, and C4 usually normal. C3C will be going up, and sometimes probably can be low. Factor B, which is on the top, factor B can be low. The most important biomarker is the soluble C5b9, which when this complex C5 to 9, it's not on the membranes, it's formed in the solution, we can capture by using your plasma. So when here, just an example, around like 50% of the aHUS patient has the elevated C5b9. These patients, we think they may be better respond to the eculizumab, which is also another name is Solaris, you're all familiar with. So come back to the autoantibody. Autoantibody testing is the most important for aHUS, and this first reported 2005, I think. Then we still don't know how it happened, why it developed, and maybe it's a strong associated with the genetic, because we find a lot of patients had the deletion, homozygous deletion of related G3 and 1. And it's also could be like something to do with the previous infection. So usually we find a patient in the 5 to 10 year old patient, and it can be also found in adult patient. So the most unique for this test, because this is quite a simple test like ELISA, and I think if people working in the medical field, and I think people familiar with ELISA, it's everyone can do, but our test is unique because we have been standardized to internationally recognized standard. That means if you do the test here, it's probably you get the same results if you test in the Europe or somewhere else. Then the normal reference range we set at 200, which is after we're looking at 300 normal patients, we set up a cutoff, and it's a lot of work from the functional team too. Then we also set up a gray area, which is 200, 500. We don't know. This is maybe slightly above normal, but we don't know the significance. Usually we see the patient is much higher than 1,000 arbitrary unit. So we think like if the patient is below than 1,000 arbitrary unit, should be okay, and should be. I'm not a physician, but if ask me, people can maybe off the eculizumab. So that's also another part. It's important to follow up your biomarker over the course of time, because this factor H autoantibody can up and down over the course of the disease. That's the other correlation study, and it's really have a good correlation that when the factor H autoantibody high, the disease is getting worse. Factor H autoantibody lower, then the disease is getting kind of in the remission. So I briefly touch up with these two assays, because these are both looking for the pathway activity. We screen for the entire complement system. So CH50 is for the classic pathway, and AP functional assay is for the alternative pathway. Any of the components, like on the Richard's slides, any of the C1 to C9 missing, any of them missing, it would give the abnormal results. So this is an easy and simple test. We don't need to look at the individual protein. We just look at the entire pathway. We can tell you what is going wrong. And so this test is, we usually looking for the 50% lysis using the shipper erythrocytes. And then previously we used like aPH50. There another test, aPH50, which use the rabbit cell. But right now, everyone is going to the ELISA-based modified version, which is called APFA, which is in the simple. So under the treatment, that should be really suppressed, and CH50 should be undetectable, and the APFA should be kind of a normal. So finally, I would be talking about this hemolytic assay. This is a really simple assay, but this is the most important assay for aHUS patient. So this patient, we also use the shipper erythrocyte, but the shipper erythrocyte is the non-active surface for the human serum. So if we just simply add a normal serum, that means its complement won't like deposit on the shipper erythrocyte surface, and it won't like lysis cell, because you have the normal factor H. So normal factor H would just attached on the surface, then degraded those C3b deposit on the surface. But if factor H function is compromised by either presence of the factor H mutation, or either have the fusion, genetically fusion protein, or factor H autoantibody, this will be turned something like something abnormal. So that's hemolysis, which is the lysis, those red blood cells release the hemoglobin, and we see that that's abnormal in the patient, aHUS patient. So I would like to thank you, and thank you first of all coming to the Iowa. And this we gain a lot of knowledge over past 10 years, because we by studying your sample, and that's really important. And thank you for donating the blood and give us the permission to study your sample. And I also would like to thank the entire CDS team, and all these people doing the kind of a bench work, and they did a wonderful job, I think. Thank you. Yeah.
Is that a diagnostic tool for any other diseases besides TTP and aHUS?
This is only.
Question, please. No, let her repeat.
Okay. So the question is the ADAMTS-13 test is for all other disease, for all other non-aHUS disease, right? Is that the correct one?
My question is, does a doctor send in a test for ADAMTS-13 for any other disease besides TTP or aHUS?
No, that's the test is only for TTP. Particularly, it's specific for the TTP, not for any other aHUS, not for any other TMA disease.